let us now create our final spider. So here we have our spider walker, and we are going to select all of these animations, and we are going to drag and drop them here in our scene. And I'm going to take the animation and its controller, and I'm going to put it here in our spider walker animations folder. So now we can simply select, let me just select my animation here. So I can select, and we see that we have this one empty frame, so we can simply select it and we can delete it. And now I'm simply going to, reposition these frames here. So this is what we have here. And now when I run the game, we see our spider walker walking. And let me just correct this here. So let me just move this animation and this one again. So everything is okay. So I thought that we had a problem, and that's why I tested it. So now if we run it, this is what we have here. So we have our spider walker walking. And we are not going to create idle animation, so on and so forth. This is the only animation that we are going to have for our spider walker. I'm also going to apply a box collider on our spider walker, and I'm going to edit it a little bit. So like this, and place it here on our spider walker. So I'm going to place this one below his feet a little bit, because we need to simulate that he is walking on his feet, and this is what we have here. And let me just go here in the animation. I don't know why these animations are also applying here. I have no idea. It seems that when we create an animation, we need to play the game like this, or otherwise then anything else that we do will apply to that animation itself. I also noticed that for our spider jumper. So if we select the spider jumper, for the attack animation, we see that the collider also has these animations here, which we don't want. And then we need to play the game in order to not have animation register every arm move. Anyway, moving forward for our spider walker, we are going to apply a rigid body on him, and I'm going to freeze the Z rotation. And here in our scripts folder, I have created our spider walker, which I'm going to apply here. So I'm going to filter for our spider walker script and apply it here on our spider walker. And now I'm going to save him in our prefab. So here we have our spider walker prefab. And we can now simply open our script in MonoDevelop, so that we can work with it. So as always, here we need a private rigid body, which is going to be my body. So my body, not my void. And we also need a public float. So here I'm going to create a public float speed. So speed is equal to, let's say 1. And this is the speed by which we are going to move our spider. And I'm going to move our spider in the fixed update. So instead of update, I'm going to call fixed update. And also here, I'm going to create a void move function. And what we are going to do is we are going to say my body.velocity is equal to, and we are going to apply new vector 2. For the x, we are going to use transform.localscale.x, and for the y, we're going to use 0, and we are going to multiply that by our speed. So for the x-axis, or the velocity on the x-axis, we are going to use local scale x. And simply we can call this here in our fixed update function. So now if I run the game, we are going to see that our spider walker is walking. So we have a null reference exception. Oh, I forgot to call here in our void awake function. We need to get a reference to our body. So my body is equal to get component. So get component. I hate it when MonoDevelop does not offer our autocomplete. So get component rigid body 2D, and we need to close this with parentheses. And let me just close it or remove these errors that we are having here. And now when I run the game, we are going to see our spider walker walking. And let me just apply gravity scale 2 for him so that he will automatically fall down quicker when we run our game. So here we have him walking. And let me just apply 3 for the gravity scale. But what we need to now, or what we need now to do, and again gravity scale 3. What we need to do is we need to register when we go here. So we don't want our spider walker, when he comes here, we want him to turn around. So how can we do that? When we need to go back here, and we need a couple more variables. So here we need a serialized field. This is going to be a private transform, and this is going to be our start position, and this is going to be our end position. We also need a private Boolean variable which is going to detect collision. So we are going to name it collision. And here I'm going to create void, and I'm going to name this one change direction. And inside of this function, and I'm going to call it here below our move, and inside of this function we are going to detect our collision with our ground here, so with the ground, and then we are going to see when we are not colliding with the ground anymore in order to change our direction. In order to detect when we are not colliding with our ground anymore, we are going to use a line cast. So I'm going to call our collision is now equal to our physics2d, so physics2d dot line cast, and we are going to pass our start position, so start position dot position, and our end position dot position, and here we need a layer mask. So this is the syntax. So this one, and then we are going to say our layer mask dot name to layer, and here we need to pass a name for our layer. So this is the ground, so we are passing for the ground. If I go back here and if I select the ground, we see that we have here a tag and we have a layer. When we click on the layer, we have a default and these other layer names. This is the name to layer that we are going to use in order to detect if we are colliding with the game object that's on the layer with the specified name. So we need to go back and create a layer ground. So click on this drop down list, add layer, and we need to add a ground layer. And let's tag our ground with this layer, so layer ground. And as I said, this will check if we have a collision with a layer or with the game object that has a layer named ground. So now what we need to do is we need to check if we don't have the collision anymore, because as long as we are colliding with our ground, we are good to go. So as long as, let me just select our spider walker, as long as we are colliding with our ground, we are good to go. But when we don't collide with our ground anymore, we need to change our direction and move in another direction. So that's why we are checking if we don't have a collision anymore. I'm going to get here our local scale, so vector temp is equal to transform local scale. We are going to check if our temp x is equal to 1. If this is true, then our temp x is equal to -1 in order to reset it. Else, then our temp.x is equal to 1. So we are checking here again if our temp x is equal to 1, meaning that our spider is facing the right direction. And now we need to change the direction, then we also need to change the scale. So now scale is equal to -1 so that our spider will face the left side. Else, if our spider is facing the left side and we are changing the direction, then we need to set our local scale to 1 in order to change that direction. And here we need to say our transform.local scale is equal to temp in order to reset it back. Now for our end and our start position, I'm going to go back here and I'm going to create an empty child for our spider walker. So create empty. I'm going to name this one end position and I'm going to tag it here with this red icon. We need to select our spider walker, and for the start position, I'm going to set the spider walker itself, and for the end position, we are going to set his child. And I'm going to hit apply so that this applies to our prefab. But I'm going to take our end position and place it here so that when our spider walker comes here, and here we are not going to collide with our ground anymore, and then we are going to change our direction. So I'm also going to demonstrate this, so let me just run the game now. So now we see our spider walker walking, and notice now when he does not collide with the ground anymore, he's going to change this direction, which we just saw. In order to make this more clear, I'm going to go back here and I'm going to draw a line. So here I'm going to say debug.drawLine. So draw line, and I need to pass the start and the end position. So start position dot position, end position dot position, and I'm going to use color dot green so that we are going to draw a green line. If I go back now in our scene view, we are going to see this green line. So here it is. So we see the green line, and notice now when we don't collide with our ground anymore, we are changing the direction. And that's why we are using here in our move function, we are using transform local scale multiplied by the speed in order to move our spider, because when our scale is equal to 1, we are moving in the right direction. When our scale is equal to -1, we are going to start moving, excuse me, I'm lost here a little bit. We're going to start to move in the left direction. And we are doing it here. So here we are changing that direction. And I've set this variable to be public for the speed so that we can alter our speed. I'm going to remove the start function because we don't need it. And we can also alter our speed here in our editor. So I can pump up the speed. So let's say speed is, I don't know, 10. We see that our spider is moving like crazy. So we are practically done with our spiders. And now simply hit apply so that everything applies to our prefab. The last thing that we need to do inside of this script though is we need to go here and create on collision enter 2D. This function, as we know, takes a collision, so collision 2D, and I'm going to name it target, and we're going to test if our target dot game object, so game object dot tag is equal to our player, meaning that our spider has touched the player, destroy the player. So simply destroy target.gameObject and save this, and we are practically, as I said, finished with our spiders.